Oh, okay. Let's start the class. So today's section is about strategies, how to evaluate the integrals. And now we're going to have all kinds of integrals, and we have to decide which method we're going to use. Okay. So anyway, I'm going to begin with the problem x plus 4 over x squared plus 2x plus 5 dx. Okay. All right. So first of all, yeah, you look at the denominator. Can you factor this? And the answer is no. Okay, so that means it doesn't have zeros. So therefore, you can try to express it as a standard form. Okay, you add the 1 and you subtract the 1. So it's 5 becomes 4. Okay, so the first part will be x plus 1 squared and then plus 4. Okay. So now it's a natural idea to introduce a new variable, okay, which is going to be, I want to get rid of 4, so it's 2u equals x plus 1. So when you square it, I get 4u squared, so 4 will be cancelled out, okay? And 2 du equals dx, okay? Then the integral, the above integral becomes, okay, first of all, 2u squared, right? And what is x plus 4? X plus 4, you know, x plus 1 is going to be 2u, right? So it's 2u plus 3, right? You change x plus, x is going to be 2u minus 1, then plus 4x plus 1. And then dx is 2 du, okay? So this is a new integral, and then let's simplify a little bit. I have a 4u squared plus 1, 2u plus 3, so it's 4u plus 6, right? Du, okay? So that'll be 2 parts, okay? You get u over u squared plus 1 du, and you get 6 plus 3 over 2, and this, right? You know, the second one, we know that, what is antiderivative of this, right? This will be inverse of a tangent to u, right? The first one, you use another substitution, okay? So if you use another substitution, if you let w to be u squared plus 1, that is going to be integral of w. U times du is going to be half of dw, okay? So that would be 1/2 of nature of w. W is always positive, so don't worry about that, but it's very simple. Okay. So my answer is going to be half of nature of, right? And plus 3 over 2 inverse of tangent u. Okay. Then you replace u by x, right? So then you replace u by x. X is half of it. U is half of x plus 1. All right, that's it. So we solve the problem. All right, so throughout this section, we're going to discuss all kinds of different type of problems, okay? So the question is, what is strategy? What is how do you start with, right? The first step. something like square root of x, 1 plus x, and dx. Okay. So when you get the equation like that, and when you get the integral like that, what is the best way to solve the problem? I think this is just a sum of a power function. We know how to solve integral power function. Okay. Don't try any substitutions. That'll be more complicated. So this is going to be square root of x times square root of x times x, right? Okay. This is pretty annoying. This is always short. Too sensitive to my screen. Okay. All right. So antiderivative of x to the 1/2, right? Plus this 3/2 dx. So you find antiderivative of each of them. It is going to be, right? The second one, n plus constant. Then you simplify. Right. Now, if you really want to use substitution, you probably can get it, okay? But does not simplify the procedure. Okay? So if you can express it as a sum of power functions, and you should go for that first. So you simplify this, you will get 2/3, x is 3/2, is 2/5, x to the 5/2 plus constant. All right, similarly for this problem, and you can think about, okay, if you are given this integral, right? Now you may try to use substitution. But my suggestion to you is to express as a sum of power function. Yeah, you can use a substitution, no problem. You can use substitution in this case. U equals square root of x. Okay, then du equals, right? So that's why you can you can get that's right, you can get here on the top, right? It's 1 plus x is a u square, right? And the dx is twice of that, 2 du, right? Then you find the antiderivative of u, that's 1. 1 is u, and this will be 1/3 u cubed plus constant. Then you replace it by square root of x. So just the square root of x, and here 1/3 square root of x cubed and plus constant. Okay. Now, if you do not use a substitution, I think it's slightly simpler, because this can be 1/, right? And this is square root of x dx, right? 1 divided by square root of x and plus x divided by square root of x. Then you find the antiderivative of each of them. Okay, the antiderivative of the first one will be, negative 1/2 plus 1 here, x to the negative 1/2 plus 1. And this is 1/2 plus 1 here, x to the 1/2 plus 1 plus constant. And after you simplify, you get the same result. It's 2 x to the 1/2, and here 2/3 x to the 3/2 plus constant. Exactly the same answer. Okay. Sometimes it can be a polynomial, but it's better to use a substitution, like something like this. Okay, I'll give you a little bit of time to think about how to do that. Okay. Well, x plus 1 to the fifth is a polynomial. Yes, if you know all the coefficients, you can solve the problem. But not everybody can quickly write down all the coefficients after you expand it. Yeah, I'd like you to think about this. Okay, I hope you already get an idea. So technically, you can always expand x plus 1 to the fifth as a polynomial. And if you write down all the coefficients, then this will be integral polynomials, no problem. But the best way to solve this problem is a substitution, okay? So du equals dx, and that is going to be u to the fifth du, right? And what is x? X is just u minus 1. So then it has become a very simple polynomial, right? U to the sixth minus u to the fifth. Okay? Then the antiderivative u to the sixth is 1 over u to the seventh, 1 over 7 times 2, right? And here's 1 over 6 u to the sixth plus constant. And we're done. Okay? You replace u by okay. But now if it's x squared plus x plus 1 squared, then you probably don't use substitution. You can quickly write down what is x plus 1 squared. Right. How about this problem? Integral of cosine x plus sine x and square dx. Right? When you see problem like that, you immediately will think about, we know how to evaluate the cosine squares. We know how to evaluate sine squares. Right? But what is the cosine x plus sine x? But this can also combine into one function. If you know that how to do it. Okay. So most of the problems you can have multiple solutions. Okay. Multiple solutions. The answer should be the same. Answer may be expressed in different form. So the best way to solve this problem is use square it. Okay. Then you find out x squared plus sine squared is just 1. And the 2 cosine x sine x is just sine 2x dx. So the antiderivative is just equal to x minus cosine 2x divided by 2 and plus constant. Right? Okay. Of course, you can change in different form. For example, cosine 2x is going to be 1 minus 2 sine square x, right? Divided by 2. So I can express as 1 minus 1/2 plus sine square x plus c, okay? So the answer will be sine x plus different student may have different answer, another constant, okay, another constant. So maybe I put C1 here, okay? right? Is there any other method you can? Other method is not trivial, okay? Remember cosine pi over 4 plus x, right? Or sine. Sine pi over 4 over x is going to be sine pi over 4 cosine x plus cosine pi over 4 sine x, okay? Now cosine and sine, they have the same value. They're all square over 2 over 2. So you end up with cosine square, cosine x plus sine x. So cosine x plus sine x can be viewed as one single function. Yeah, I just happen to remember this. Okay, so this is the identity. Now, if you use that identity, you can also, you don't need square, you can, yeah, when you square it, you can just integral of sine square. And we know how to do this, okay? So this is another possible way, but it's more complicated. I don't recommend. But it's better to know this identity, okay? Okay, try this, sine x, sine 2x dx. Okay, I also let you to think about the best way to solve the problem, okay? Now, if you always figured out this idea before I show you how to do it, and then you probably don't need to do the homework, you're okay. Okay, I'm going to give you about 1 minute to think about it. There are actually multiple ways to solve this problem. Okay. Okay, now, there are a couple ways to solve this problem. One is to express sine x, cosine x, sine x, sine 2x as a sum, of two single functions. Okay, if you do this, then you can solve the problem without any question. But another way to do it, because sine 2x is so special, okay, it's easy to memorize this, cosine x, sine x. Okay, so it is going to be 2 sine square x cosine x. Then use a substitution. Okay, that's the best way to do it. Use a substitution, u equals sine x, then du equals cosine x dx, and this is a du, right? So it's 2 u square and du, and then that's just u cubed plus constant. Okay, so and then sine cube x plus constant. I think this is the best way to do it. Now another one is you probably don't remember the formula, and sine alpha, sine beta, is going to be cosine alpha minus beta and cosine alpha plus beta, okay? And there are the three I don't want to mention here because this is the one we can use when you see sine alpha. So in that case, okay, and if you use this formula, and you will get integrals that sum of, as the difference of these two angles would be negative x, right? Okay, and then minus cosine x plus 2x, 3x. Then the antiderivative, cosine negative x is cosine x because it's an even function. So the antiderivative cosine x is sine x. The antiderivative of cosine x is sine x. So, but you have to divide by 3 here. So you know you get totally different answer, but I know this is the correct answer, okay? You can modify it and eventually you can get sine cube x, okay? Yeah. Yeah, so there are two different ways to solve the problem. So different approach, you get different form of the answers. Is there any other methods? But I think the second method is better because if you have to evaluate sine x, for example, sine 5x dx, then you cannot use the first method because sine is 5x, I don't know, right? So the only way you can use is the only method you can try is the second method. That's why I recommend the second method, cosine the difference of these two angles 4x, negative 4x, minus cosine the sum of this x plus 5x is 6x, okay? Then is the antiderivative of the first one, and still cosine 4x is negative 4x to cosine 4x. It's odd, it's even function. So it's going to be sine 4x over 4 and the sine 6x over 6 and the plus constant. You see, it's pretty quick. Okay, our next problem is going to be tangent the cube x secant cube x dx. Okay. So yeah, I still give you 1 minute to think about. I hope you get some ideas. right? Got an idea? So this is a pretty challenging problem, okay? I know I have to record some formulas, okay? So maybe get some idea. The derivative secant x is going to be tangent x, secant x, right? And the derivative of a tangent x is going to be secant square x. Okay, I also know some formulas like 1 plus tangent square x equals secant square x. Okay, so probably that's enough for us to do. What I'm going to do is the first part, I separate. Again, I express as because cube, right? Cube, so I can, one is tangent x secant x squared. That's a pretty standard technique. Then I think this is just the d, right? du, if I let u to be secant x. Okay. So let u to be secant x. Okay. Now, so I'm going to try this substitution. Then du equals tangent x secant x dx. Okay. Right? Now, how about tangent x secant x? Well, if I express in this form, maybe it looks bad. Okay. I still go back to this form, tangent square x secant square x, right? Then tangent square is going to be secant square minus 1, right? So it's u square minus 1. And the secant square x is just u square. And that's a du, then great. After it's expressed in this form, then it's just integral polynomial, okay? So it's u to the fourth minus u squared du, and the 1/5 u to the fifth minus 1/3 u cubed plus constant, okay? And then you replace u by secant x. But there are other ways to solve this problem, just a little bit more complicated. Use a different substitution. So I'm not going to try this. Yeah. Okay. How about this? Well, it sounds like there's no other choice, just except using this substitution, right? So du equals this. So the integral becomes e to the u. What is x? X is going to be, dx is going to be 2 square x du, right? And square x is going to be u. So u du, it's not too bad. Yeah, we know how to evaluate this integral, right? It's not too bad, right? It's u and eu and du, right? So that is my dv. I use the integration by parts. So v is going to be e to the u, right? Right? So it's uv minus v du. U is e to the u minus integral e to the u du. And I think that's it. Okay, so you replace the u by square of x, thing like that. So here we use the substitution, the natural substitution, and also you use the integration by parts. Okay. All right, I'm wanting to try this next problem. I'll give it half a minute. This is an easy problem. Right. So the natural substitution is going to be the natural log. Yeah, let right u to be natural log of x. So du equals 1 over x dx. Right. Then you put it here. This is 1 over u and just du, right? Yes. So it's natural log of u plus put up a very simple here, don't forget. Right. So that is going to be natural log of absolute value natural log of x plus constant. Right. Our next problem is going to be the integral of this. All right. Now, what is the best substitution? We can try. Well, there are a couple of ways to do it. You can let u to be square x, maybe, right? You don't like the square x, then you let u to be square x. So du equals, if it's not working, we have to try a different way, okay? Du equals this. All right, so this integral, x is u square, and u, right? And the dx is going to be 2 square x du, and that's 2u du, right? So it's 2u du. I hope I can simplify it. Right? That works, yeah. So you take 2 out, you get rid of 1u, and so u squared. So you get a rational function. Right? You get a rational function, and you know how to do it, right? You have to decompose it. And that is going to be u over 1 plus u. So I guess I'm going to get like a 1 over u minus 1 over plus u. Yeah. Yeah. So take the denominator's product of these two factors. The numerator is 1 plus u minus u, just 1. So this is going to be integral 1, right? And then you know how to find the antiderivative. That plus constant. So what is u? U is a square of x. So you put the square of x here. yeah, you don't need to put absolute, very simple because this is always positive. Okay, start. So that's it. Oh, 1 to 2 goes to 1/2. Oh, that's much. That's 2. Sorry, I don't know. Okay, just copy 2. When I copy 2, it's become 1/2. Okay, so our next problem is, okay, what is the best way to solve this? Think about it. Okay, I'll let you to try first. All right, when you see this problem, first of all, you should know that this is a rational function. So please, the standard way to solve this problem is to use the method we learned from last class. So what I'm going to do is I'm going to, because the degree of the numerator is the same as degree of the denominator, so I'm going to divide by 1 plus x. So it's 1. It's -1. So I get -1 minus x. Then you do subtraction, I get 2. So that means 1 minus x, 1 plus x is going to be, the remainder is 1. As a quotient is 1, the remainder is 2. Okay. So I can use then it's become pretty simple, right? And you can find the antiderivative of each of them very quickly. It's going to be, first one is -x, second twice natural log absolute x plus 1. Okay. You can also use the substitution. Okay. The substitution problem is a smart idea. If you let 1 plus u, so you can express as the sum of power functions. If you let substitution, if you choose substitution, so let W to be 1 plus X. Then this integral, okay, first of all, dx equals W, right? So that's W. Now what is 1 minus X? X is going to be W minus 1. So it's 1 minus X, and dx is just dW. It's not too bad. It's going to be 2 minus W dW divided by that. So I'm going to separate. Okay. Right? And that's working. So it's 2 natural log of absolute W minus W plus constant. What is W? W is 1 plus X. Okay. Then we get same result. And this substitution actually works nice, especially like a problem here, X plus 1 here, and X minus 2 squared dx. If you use a substitution, you can express as a sum of power functions quickly. Okay. If you don't use a substitution, and that would be, you have to, this is a rational function, right? So you have to decompose it. Okay, it's not that trivial. Okay, let's try this. Okay, so let's use a substitution. The reason I can use a substitution is there's only one single term in the denominator. So du equals dx, x is going to be u plus 2. So my integral x is u plus 2 plus 1 is u plus 3 and u squared du, see? Then you will get 1 over u plus 3 over u squared. Okay, du. The antiderivative of the first one is natural log of absolute u. The second one, you have to be very careful, it's actually 3u to the negative 1. Okay. 3u to the negative 1. Okay, so this is answer. Okay, then you replace u by x minus 2. Then, now, what else? What other methods you can use? Well, go back to x plus, yeah, what is my function? X plus 1, here x minus 2 squared. If you, you can decompose it, okay? First of all, the degree of the numerator is smaller than the degree of the denominator, right? So you don't need to simplify the functions in long division. Right? But since it's x minus 2 squared, so the book suggests you get this type of form. Right? So you can determine the constant, A and B. Okay. Right? You can find the A and B, okay? No problem. So what is A and what is B? And actually, you can get A is 1, B is 3. Okay. A is 1, B and 3. Okay. I just skip that part. So this is the second method because I just give the sketch ID. You get this, then you integrate each of them. Okay. Right? X plus 1, x minus 2 squared dx. So how do you evaluate it? How do you evaluate the second integral? Well, remember, yeah. After you use a substitution, this is going to be absolute value, right? Right, plus constant. Now, when it's in other power, x minus k to the nth power, as long as n is not equal to -1, right? Here n cannot be -1. And those are the two general integral we need, we know how to get it quickly, right? How to evaluate. So using the above two formulas, so the integral of this function is given. First of all, it's given over x minus 2 and plus 3. I think n is -2. So -2 plus 1 and x minus 2, -2 plus 1 plus constant. Okay. So, so therefore, you will get the same answer. All right, let's double check. Yeah. Okay. What do we get? The first method using the first one. Yeah, we get the same answer. See? Okay, we get the same answer. Okay. So I want you to think about this. Okay, please. All right. So what kind of substitution we can try? I think x to the fourth power is too high, right? So I can try let u to be x squared, then they get a u squared plus 1. Right? Maybe that works. Let's see. So du equals 2x dx. Let me try this. And so I don't know what is x here. Leave it here. It's x u squared plus 1. Dx is 2x du over 2x, right? Yeah, you solve for dx. Then, and you will get 2x squared u squared plus 1 du. And the x squared is u, so not too bad. All right, so this is a typical rational function. And u squared plus 1 cannot be factored. So u times u squared plus 1. And the book suggests you here have 1 over u, right? It's a over u. And 1 over u squared plus 1, yeah, you should be able to get the bu plus c, and here's u squared plus 1, okay? So it's not easy, yeah, let's just find the decomposition. So let's determine the coefficients. Right, be patient. Okay. Plus u times to bu plus c, okay? And then you compare the coefficients. I think u square, yeah, this is going to be a plus b u square, right? And then you have a cu, right? And then you have a, the last term. What do you have to have? A must be equal 1, c should be 0, a plus b should be equal to 0. So that means b equals -1. So it determines the coefficients very quickly. All right. So we have a and b, right? And c 0. So the above integral becomes a is, right? And c, b is -1. So it's u squared plus 1. What do we get? And the antiderivative of the first one is natural log of 0 u. The second one, natural log of u squared plus 1. And then you have to divide by 2 because when you differentiate, you get 2u on the top. That's it. What do we do there? We let u to be x squared. So we have to change it and change u by x squared. This is x to the 4th power now. Okay, then. Well, we can do that, right? All right, so our next problem. All right, so think about this, okay? Yeah, what is the best way to solve this problem? This is just a typical rational function. I hope you can figure out how to do it. Okay. The degree of a numerator is smaller than degree of denominator, so don't worry about, you don't need to divide the numerator by the denominator to reduce the power. Okay. Then you look at the denominator. It's x squared minus 4x plus 3. It has zeros. It has zeros. Okay. So quickly infract it. Here's x minus 3 and x minus 1 dx. So you have two different factors. So it can be done, it can be expressed in this form. Okay. There's a quick way to find the A and B, just to try, I guess, and try. But let's let's combine them and determine the coefficients. Let's, right. So here's x minus 1. This is a b, x minus 3. All right. So a plus b is the coefficient of x, which should be equal to 1. Okay, then negative a minus 3b is going to be negative 2. Oh, well, funny. All right, so just solve this system linear equations. Okay, you can add them together, and you get a negative 2b and a negative 1 here. So b is going to be 1/2. If b is 1/2, a is also going to be 1/2. Wow. All right, so then you can solve the problem. Okay. It's going to be integral of 1/2 x minus 3 plus 1/2 x minus 1. Right. And the 1/2 the same constant. Okay. All right, let's try this. Okay, please work on it. Okay, it's a sine square x divided by square x. Okay, please do it. All right, so when you look at this problem, you don't like the square x, right? So it's natural idea to use a substitution to get rid of square x. Right, so you can do this, right? So you let u to be square x and du equals this. All right, so now you get sine u, and there should be no radical, no nothing, yeah, no denominator, right? So here, if you put a square x here, then dx is going to be 2 square x dx. Right? It'll be canceled out. So it's going to be 2 negative cosine u plus constant, because the antiderivative sine u is cosine. And so the answer will be negative 2 cosine cosine u is going to be right? So here's the integral of this is the integral of sine 3x cosine 5x dx. All right. So when you see sine, cosine are the different angles, right? You have to use a formula which gives the sum of two single trigonometric functions. So the formula we're going to use is going to be, it's a sine alpha cosine beta, right? So sine alpha plus beta plus sine alpha minus beta. Okay, so it's going to be sine 8x and minus sine 2x. I should put the integral symbol here. That's right. No. X. It's too late to put the constant here. So it's dx. All right. So then antiderivative of sine 8x is be negative one cosine 8x divided by 8, and this will be positive cosine 2x divided by 2. Right? This will be the antiderivative function. However, it is a sine 2x cosine 2x. In this case, you don't need to use the above idea because those are two angles the same, 2x, right? So you can express it sine 4x. All right, then you get cosine 4x over 4 plus constant. All right, let me ask you to go over this problem. Yeah, let me ask you to solve this problem. Okay, I'll give you 1 minute to think of what is the best way to do. All right, so for this problem, I have a couple ways to do it because x plus 1 is really not, it's not complicated. So we know the formula, right? So it's x cubed plus 3x squared plus 3x plus 1. Then you get x to the fourth power, 3x cubed and 3x squared and x. So it's polynomial. Then you write all the terms, right? Did he use this idea? And did he use this method? Right, it's quarter x to the fourth power and 3 over 4 x cubed and 1/2 x squared and plus constant. All right, of course you can use substitution. And that's what we did at the very beginning. Okay, the substitution is, let u to be x plus 1. Okay, then and then u is going x is going to be u minus 1. So the integral becomes u minus 1, u to the u cubed, and dx is just du. Right? So u to the fourth power u cubed du, and you know how to find the antiderivative. Right, then you replace u by x plus 1. Now, those two look quite different, but after you explain it, you get the same answer, okay? So only differ by constant. Yeah, only differ by constant. But the second one looks simpler, just only 2 terms here. Okay. All right, one more, x minus 2, x squared minus 2x plus 5 dx. Okay, this will work out this. Okay, this will be our last part. I'll give you 1 minute to think about it. All right, so when you see the problem like that, okay, there are a couple ways to do. Okay, one is you realize that there's only one term, one linear term in the denominator, okay? So if you use a substitution, actually it's not too bad idea. Substitution, you let u to be x minus 2. So x is going to be u plus 2, right? So here's u, x is u plus 2 squared minus 2, u plus 2, and plus 5, and dx is just du. Okay? Then we expand the numerator, okay? So it's going to be u squared, this is u squared plus 4u plus 4, right? Minus 2u minus 4 and plus 5. So again, it's u squared plus 2u. 4 minus 4 is gone, it's just plus 5. Okay. Then you have an antiderivative. Then you have u plus 2 plus 5u du. Okay, so the antiderivative of this will be half of u squared 2u plus absolute value, natural value. Okay, then you go back to x minus 2. x minus 2 squared plus 2, x minus 2 plus 5 natural log, x minus 2 plus constant. All right, so this is I think it's a good idea using substitution when you only see one linear term in the denominator. Of course, you can use a long division to simplify the expression. All right, yeah, simplify the expression. So you get x squared minus 2x. Okay, it's going to be it's going to be just the remainder is 5. Okay, so x squared minus 2x plus 5 over x minus 2 is just equal to x plus 5 over x minus 2. Okay. In this particular case, it's very simple. Okay. So the integral is antiderivative of this. It's given half of x squared, then plus natural log of 3 minus 2 plus constant. I did a lot of exercise today here. I hope you can figure out the ideas with a given 1 minute. Okay, and if you always have trouble to solve the problems, cannot figure out what is the best way to do, then you need more practice. Okay. Yeah, that's it. And we have a class offline.